What's up, stats? This is Mr. Carlson with C Squared Mathematics. This week is the last week of Unit 7, Probability, and we are going to be going over probability distributions. So, for the next 3 days, we're going to go over probably 3 or 4 different probability distributions, and we're going to learn what they are today. So yeah, what are probability distributions? How can I use this graphing, this distribution in a specific way? How can I utilize probability in that distribution? And then what does it mean for us moving forward before we get to stats? Okay, the statistics unit. That's going to be very, very important for us. So let's just get started right into it. We're not going to go through bell work, just straight up through the notes. So our essential question is this: how are probability distributions used in order to find probability and expected value? How are they used in order to find probability and expected value? We're going to be learning a lot of new stuff today. This is just your very basic introduction to what we call probability distributions. And we're going to be consistently using these distributions all the way throughout the whole quarter, which means we're going to be even using them in statistics, our unit for stats, unit 8 stats. Okay, so this is a very, very landmark, important lesson. So let's go to town. So before we go anywhere, I just want to tell you that there is a video right here. If you click on it, we're not going to watch this video. Very, very cute. It's just being very, very slow. So sorry about that. This right here is the course, crash course for statistics. I just wanted to remind you that it's here. We're not going to watch this in class. Obviously, you guys can watch it yourself. But I highly encourage you that I'll just tell you whenever I have a link up there, I'll just show you that this is what it is. It basically goes through just what we call distributions. So we're in our distributions week. So we're going to go through a lot of distributions, probability distributions. And it basically just goes through different distributions such as height and different kinds of probability distributions that we might be learning. Okay, I just wanted to tell you about that. She's awesome in a lot of different ways. If you want to watch it, then by all means you can watch it, but I'm not going to. So let's just get to our definitions here. So first of all, a random variable x represents a numerical value associated with each outcome of a probability experiment. What does that mean? Okay, we're going to talk about this, what we call this random variable x, okay, in a little bit. More on this later. But I just want to remind you, you can be taking notes. You should be taking notes right now on your packet. If you printed out the packet from Google Classroom, that's great. Even if you have the key, that's awesome. If you want to just follow along with that packet, be my guest, but make sure you are taking notes. Okay, so random variable x represents a numerical value associated with each outcome of the probability experiment. So these two outcomes can be literally what we call discrete and continuous. So these are two types of random variables called discrete and then continuous. So a random variable is discrete if it has a finite or countable number of possible outcomes. So for instance, how many students are in my class? Well, there's 0 right now. But if I had students in my class, what's the discrete value of students? Well, I can't have half a student. I can have 1 student, 2 students, 3 students, 10 students, 50 students, but I can't have 50.517 students. Okay, I can't have 2.5 dogs. I can't have 1.5 wives. I mean, I could, but I don't know what the 0.5 is, and plus that's, I'm pretty sure, illegal. Okay, so I can't have that. So it's a countable number set. So it's literally a whole number. Think about that. It's a whole number. Okay. A random variable is continuous if it has an uncountable number of outcomes, possible outcomes, represented by an interval on the number line. So what does this mean? Well, this means That's continuous if it's like a fraction or a decimal. So pi, 3.14, okay, that is a continuous data set because it's a fraction. Okay, 3/4 is a fraction. Okay, 3/8 is a fraction, which means it's continuous. Okay, it's not a whole countable number. Okay, the number of unicorns in my room is 0, real life unicorns. But number of unicorn things in my room is a countable number. The number of Spider-Man things in my room is a countable number. The number of siblings I have is a countable number. All of those are discrete, whereas continuous is such as, my age. My age is like something number. I'm not going to tell you my age, but some number plus like a couple months and then a couple of days, right? My height is a continuous number because it's 5'7 3/4". Yes, I'm that short. Okay, 5'7 3/4". My shoe size is like, I think 10.78 or something. It's like close to 11, but not really. All right, so that kind of thing, that's what we call continuous. So let's go through a couple of examples. Let X represent the number of Fortune 500 companies that lost money in the previous year. So is this discrete? Well, there's Fortune 500 companies. So how many companies? Well, there's 500. So is this discrete or continuous? We're going to say it's discrete because 500 is a countable set of data. Let X represent the volume of gasoline in a 21-gallon tank. Well, can you have exactly 21 gallons or can you have maybe like 21.578? Because you can have that, and that makes sense, this is what we call continuous pieces of data. Continuous pieces of data. What about the speed of a rocket? The speed of a rocket isn't just always going to be like 100 miles per hour or 300 miles per hour or 310 or 576. Okay, it's probably going to be 576.897 or something 576.12. So that means this is also what we call continuous data. Okay, continuous data. Let X represent the number of calves born on the farm, or number of chickens on Wilpink's farm, or number of pigs that she just loves having on her farm. That's going to be what we call discrete, because you can't have 6.5 pigs. You can't have 6.5 calves. I mean, you can, but then it would be on probably your dinner table and not your actual farm, right? So it's going to be discrete. Awesome. Let's move on here. So now that we know what discrete and continuous are, think about this. We're going to pinpoint one thing, and it's called discrete probability distributions. Now, there is what we call continuous probability distributions, but we're not going to be doing continuous probability distributions until Unit 8, starting with statistics, okay? So there is such a thing called continuous probability distributions. We're not going to do that until later. This whole week is what we're going to be calling discrete probability distribution. So countable data sets. So I can count like boom, 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 like 1, 2, 3, 4, 5, or 10, 15, 20, 25. It's not going to be 1.57. It's not going to be like 5.76 for my X variable. Okay, so keep that in mind as we move forward. What is a discrete probability distribution? It is basically a list. It lists each number, each possible value that random variable can assume together with its probability. Together means just adding up. So the discrete probability distribution must satisfy these conditions. Okay, I'm going to have it in words here, and then we're going to put it in symbols. So in words, the probability of each value of the discrete random variable is between 0 and 1 inclusive. What does that look like? In symbols, 0, and then my less than or equal to sign, probability, another less than or equal to sign, 1. So what does this mean? This means that my discrete probability must have a probability between 0 and 1. And should that make sense? Yes, because your probability has to be between 0 and 1, right? It has to be between 0 and 1. Now notice, this is not X. If you're thinking, well, can't that be a fraction, 1/2? Yes, but that's not your X. Your X is countable. Your probability is not. So I'm going to show you what that means in a little bit. You're going to have two values. You're going to have what we call your X random variable, and you're going to have what we call the probability variable. Okay, what we actually find, the output, the probability. Okay, so let's move on to the second condition. The sum of all the probabilities is 1. Again, this should make total sense. I'm going to use a big fancy E here. What this means is called, it's literally sigma. It's a Greek letter, sigma. It means sum. So it means adding. It means put together. When I add everything together, when I add all the probabilities together, it has to equal 1. That's what it means. When I add all the sums together, it has to equal 1. When I put all the probabilities together, it equals 1. Awesome. So that is the definition for probability distribution, specifically discrete probability distributions. Let's get to some guidelines and building these, and then we're going to probably go through at least 2 different examples on building these, and then we're going to go through verifying probability distributions, and then we're going to get to what we call mean, variance, and standard deviation. How can I find and perform operations on these probability distributions? So, guidelines. Let x be a discrete random variable. Remember, we said that this week is all going to be discrete, where x is a countable set of data. So that means 1, 2, 3, 4 instead of like 1.5, 7.6 or something, or 3 halves. Something like that, okay? It needs to be a whole number with possible outcomes, blah, 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 okay? Make a frequency distribution. I'm going to show you how to do that. The possible outcomes. Then find the sum of the frequencies. That's just adding them all up together. And then find the probability of each possible outcome by dividing its frequency by the sum of the frequencies. So by dividing its frequency by the sum of the frequencies. Okay, so find the probability of each possible outcome. The possible outcomes are my x values. Look at that. So right here, my possible outcomes are my x values because x, x, x. So I will have multiple different outcomes, and each assigned to that outcome, I will have a probability. Okay, so after I have a probability assigned to that outcome, what I do is take that probability divided by this, or take that frequency. Each outcome will have a frequency. I take that frequency divided by the sum of the frequencies. What I get out is what we call the probability. Okay, so I'll say it one more time. We're going to be given a certain number of data, countable data, discrete data, data that's not fractions, a countable set of data. Let's just say we're going to be given like 1, 2, 3 numbers. 1, 2, 3. We're going to have a frequency attached to that number. So a certain frequency, a tally mark, frequency just means tally mark, how many times it occurs. So let's just say for 1 occurs this many times. For 2 occurs this many times. For 3 it occurs this many times. I'm going to take that this many times, that frequency, that tally mark. I'm going to then divide it right here, step 3. I'm going to then divide it by the total sum of the frequencies. Okay, from 1, 2, and 3. That is how I get probability. Okay? So frequency all over the total. That's literally what the probability is, a frequency all over the total. Of course, it has to be between 0 and 1. It has to be totaled to 1 after I'm done. So let's get started. I'm going to erase. Let's actually construct a probability distribution, shall we? So an industrial psychologist administered a personality inventory test for a passive-aggressive traits of 150 employees. Individuals were given a score from 1 to 5. Notice how this is discrete. Okay, it's countable. 1, 2, 3, 4, 5. 1 was extremely passive. 5 was extremely aggressive. A score of 3 indicated neither trait. So if you got a score, you were neither a 3, you were neither passively aggressive or extremely aggressive or anything. Okay? Awesome. The results are shown right here. Constructed probability distribution for the random variable x, which is 1, 2, 3, 4, 5. Then construct a graph using a histogram. Histogram is just a bar graph. So I'm going to move this up here. We're going to get started. Are you ready? So what do I do here? Well, the first thing is first, I'm going to look at 1, and then 2, then 3, then 4, then 5. So the probability of 1 equals, follow my guidelines, probability of 1 equals, I'm going to take the frequency, 24, and then divide it by the total number of frequencies. So what's this total number? When I add them all up, that's what I need to do. I need to add them all up. Okay, that's literally the second step. I had to add them all up. We already made a frequency distribution. Now add them all up. I'll give you a second. Do that on your calculator. Go to Desmos.com, add them all up. What you should get is 150. So I take 24 divided by 150. What does this equal? This approximately equals 0.16. How did I get that? I literally just plug into my calculator. If you have yet to have a TI-36X Pro, it looks like this. You should definitely pick it up because it's awesome. Okay, definitely pick it up. But if you don't want that, if you just want the Desmos, then fine. You can plug in 24 divided by 120. You get that. All right, so probability 2. Now I'm going to take probability of 2. What is the probability of 2? Probability of 2 is 33 all over the total number, 150. When I simplify this, this gives me 0.22. Okay, just plug in your calculator. What does it give me? That's what you need to find. I find probability of 3. So this is 42 all over 150. When I plug this into the calculator, what I get is a decimal of 0.28. And then I do probability of 4. What does this give me? Well, 4 is 30, so that means 30 all over 150. When I plug that in the calculator, I approximately get 0.2. I'm going to put 0, 20%. And then probability of 5. Probability of 5 is 21 because that's 5 right there. So I'm going to take 21 all over 150. This approximately equals, on the calculator, about 14% or 0.14. Awesome. So I have all of these values. Now, my guidelines say I should add them all up, because if I add them all up, what it should equal when I add them, my sigma, when I add up all my probabilities together, it should equal 1. And actually, it does. Okay? So when I add all these up, they do equal 1, because again, probability cannot be greater than 1. So it has to be 1 or below, 0 and 1. Okay? And that's how you do a probability distribution. Like, seriously, that's it. That's all it really is. So I'm going to show you the graph, what it looks like. Let's look. Boom. So this is what the graph looks like. I'm going to erase this stuff here. So if you have yet to get it down, make sure you get it down. So what does this really say? So this is your X down here, your score, 1, 2, 3, 4, 5. And then this is what we call the probability. The probabilities that we just found. Okay, that I just erased, those probabilities, that's right here. Okay, so that means you have, for 1, we had around 0.16. For 2, we had 0.22. So this is roughly around 0.22. Okay, for 3, we had 0.28, so 0.28. For 4, we had 0.2, 0. And then for 5, we had 0.114. Okay? And so now that you can see the graph, you can kind of see it's very accurate. So you have 1 to 16 right here, 22. This is roughly 28, and so forth. Awesome, awesome, awesome. Let's erase. Let's go through another one. Let's see if we can do this one by yourself. So I'm given the same thing here. Follow the steps of the guidelines. The company tracks the number of sales new employees make each day during a 100-day probationary period. The results for one new employee are shown in the table. So I have countable data sets 0 through 7. So try to do this by yourself. But start with totaling your frequency. You already have a frequency chart given to you, which is great. This is the number of days that sales per day. So this is the number of days they basically had. So 0 sale on the 0 day, they had number of days, or 0 sales per day was 16, 1 sale per day was 19, and so forth. Okay? Great. So go ahead, pause the video. Okay, let's start probability of 0. What's the probability of 0? Well, I look, like, okay, that's 16. Oh, when you add them up, it should be 100. And now they gave that to us. If you weren't paying attention, they gave that to us at the very beginning. It's a 100-day probationary period. So that's nice, right? So it's 100 days. Now let's start. Probability of 0 is 16 divided by 100. And this is really nice because this is just straight up 0.16. Okay, because now it's over 100. Probability of 1 equals 19 all over 100. But this equals 0.119. So probability of 2, what this equals, is 15 all over 100. So this equals 0.15. Probability of 3, that's going to be 21 all over 100. So this is 0.21. Probability of 4, this equals 9 all over 100, which is the same thing as 0.09. So let's get them down here. Probability of 5. Probability of 5 is 10 all over 100. So this is the same thing as 0.10. Probability of 6. Probability of 6 is 8 all over 100. So 0.08. And then you have the probability of 7 here, which is 2 all over 100, which is the same thing as 0.02. So notice how I don't really need a calculator here. I can just look and say, oh, it's over 100. So that means it's just that percent. That's awesome, right? So 16 all over 100 is the same thing as 16% as a decimal, which as a decimal, it's just 0.16, 0.19, same thing, 0.15, 0.21, 0.09. I need to include the 0 there because I have to move it over 2 different spots to the right to make 100. This is 0.10, 0.08, 0.02. So this is how I do just a very basic probability. Okay, the very, very basic probability. That's what I have. Now, of course, if I added all of these together, if I added all of this down, 0.16, 0.19, 0.15, so forth, I should get 100, which I do. And then, of course, I can graph it. I can graph it if I wanted to, but it doesn't. Well, it does ask for a graph, but I'm not going to do the graph, unfortunately. So I'm not going to graph that probability distribution. Okay? But we could if we wanted to. Awesome. Let's erase. Now, how do I verify? How do I know if a probability distribution is an actual distribution? Like how do I know if it's truly a probability distribution? Well, I have to follow my 2 rules, right? It has to be between 0 and 1. Can't be negative. It has to be between 0 and 1. And it has to add up all the way to 1. My probabilities have to add up all the way to 1. So verify whether or not this is a probability distribution. So I look and see, okay, well, this is countable. Okay, 1, 2, 3, 0, that's countable. These are probabilities. Okay, great. So they're not greater than 1. They're not negative, so that's good. So it definitely fits that condition. But the next thing I would have to do is just actually add them. So I would have to actually add my probability distribution together. That looks gross. I'm going to erase. So probabilities. So I would take 0.216 plus, I would take 0.432 plus 0.288 plus, and then 0.064. When I add all these together on Desmos, on my calculator, whatever, I should get 1. Okay? And that is how I know it's a probability distribution. Not only is all the probabilities between 0 and 1, but when I add them all together, when I added all this together, just straight down, I do get 1. And that's what I want, okay? So let's go through a different example. Let's erase. Let's see if you guys can do this yourself. Determine whether or not this distribution is an actual probability distribution. Okay, first thing you should notice is your x's are all countable. Okay, they're all between 0 and 1. But what happens if I add them? So go ahead and add these. So plus, plus, plus. What do I get when I take my probabilities added all together? what I actually get is 1.07, which is definitely not equal to, greater than or equal to 1, which means since it's not greater than or equal to 1, that's not a probability distribution. So not a probability distribution. I'll abbreviate here. Okay? Awesome. Now, what about this next one? Oh, geez. Wow. That's unfortunate. Let's erase. Okay, this next one, try to do it yourself. Look at the fractions. Now, there's one thing that would stand out to you that tells you, yes, the x's are all countable. 1, 2, 3, 4, they're not fractions. But the probabilities can be fractions. But notice one of the fractions and then notice one of the numbers. You should be noticing this one right here, 5/4. That right there is literally a mixed number. Okay, that right there is 1 all over 1/4, or 1 and 1/4. Okay, that's what that is. That's not good. Why? Because it's greater than 1, which means this is not a probability distribution. It's also not a probability distribution because of this -1. So it fails this condition. So 0, the probability must be between 0 and 1. It fails that condition. So not a probability distribution again. Okay, it's -1. I can't have a negative probability, right? I can't have a negative I can have a 100%. I can have a 1 as a probability. I just can't have a negative probability. Okay, so if I added all those together, it would technically be between, I think, 0 and 1 in a sense, but because this one itself is greater or less than 1, that's greater than 1, then it's not a probability distribution. Awesome. We're going to town here. We have just a little bit left. Okay, and then we're going to get to Desmos. Awesome. So, mean of a discrete random variable. What does this mean? Get it? What does this mean? The mean of a discrete random variable is given by this formula. It's called mu. Okay, that's what it looks like. Kind of looks like a weird looking M. Okay, but it has, or a U. It looks like a U, but the tail is like longer in the front. So it's called mu. It's a Greek letter. Mu equals sigma, another Greek letter that means to add, and then x times the probability of x. Okay, I'm going to show you what this is in a little bit. Okay, but keep this in your brain. That's very, very important. We're going to come back to this even in the next unit. That's how important this is. The mean of a discrete random variable is given by this. Okay, it's very, very important. Okay, now each value of x right here, the discrete random variable, is multiplied by its corresponding probability that we learned how to find in the previous examples, and the products are then what we call added. That's what the sigma is. Okay, so it's literally just multiplying the probabilities to the random variables, dividing it, and then adding them all together. Okay, we don't need to divide here. So let's find out how to do the probability. So find the mean score. Okay, find the mean score of this probability distribution. Now, this is the one that we did in example 2. So in example 2, we actually did this. I think it was example 2A, 2-1. Yeah. So this was example 2-1. We got these probability distributions when we took the x's, like the frequencies, divided by the total number of frequencies. So we got this probability right here. I hope you remember that. Just scroll back. Example 2-1, the industrial psychologist administered a personality inventory test. Okay, it's about the passive aggressive traits. That's the one we did. And so now we're going to take those that we just got and we're going to add them all up. I want to know what they are added up. Well, they should obviously be 1, okay, because it's probability, right? It cannot be more than 1. It cannot be less than 0. So it needs to be 1, and I think we already verified that in that example. So that's the first step. The second step is just to multiply them. So multiply them together. Now, again, this could be done on Desmos. So you can say 1 times 0.16. So 1 times 0.16. If you want to use parentheses, you can. What does this equal? Well, anything times 1 is itself. So now I'm going to take 2 times 0.22 because that's what it says. X, these are X's, times probability, that's the dot there, times probability. So times our probability. So 2 times its corresponding probability, 0.22, 0.22 equals, and this should be 0.44. Okay? Now let's continue. 3 times 0.28, its corresponding probability, 0.28. When I get this, this should equal 0.84. And then this is 4 times 0.20. This should just be 0.80. And then this is going to be 5 times 0.14. And this is going to be 0.70. Okay? And again, I could just do this on Desmos. I can just use my TI-36X Pro if I wanted to. Definitely use that. Just literally type exactly what I've done in here, right here on the left side of the equal to sign, and then you will get those answers. It is that simple. Okay? That's just that simple. Now, I want to, of course, add them up. Okay, so that's what I need to do. I need to take all of these and add them. And so this is what my formula is for my mean. When I add them all up, x times the probability. I already did x times the probability here, 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 here. So now what I have to do is just add them all up. When I add these all up on the calculator, what I get is 2.94. Okay, or roughly 2.9 if I wanted to round, but we're going to keep the 2.94. What is this? That means this is my mu. So my mu, my mean is 2.94. Okay, that is my final answer. That is the mean score. Okay, the mean score. So the average score on this test was roughly 2.94. That's what it is for this probability distribution. Okay, not too difficult, right? It's really not that difficult. We can just have to build this table a little bit, but hold on tight because I'm going to actually give you something very helpful on Desmos where you don't need to actually build the table over and over and over again. Okay, so let's erase this. Now let's get to what we call variance and then standard deviation. What is the variance and standard deviation of a discrete random variable? So the variance. Now remember, we sort of discussed this a little bit already. About 3 weeks ago. We discussed this a little bit already, 3 weeks ago. The variance of a discrete random variable is this. Now this is going to be a lot bigger formula, but what it is, it's going to be sigma, okay, sigma squared. What is that? Sigma squared, this thing right here is just another Greek letter. It's the lowercase Greek letter of this, okay? That weird looking E is the uppercase sigma. This is a lowercase sigma. Sigma squared equals capital sigma, but I didn't do it well because apparently I don't know how to write it. Capital sigma of x minus mu squared times the probability. Now, this is what the formula is. Tons of different variables. But thank your lucky stars you have a teacher like me who doesn't require you to do this formula by hand. Okay, I'm going to show you right here where my mouse is, up here. I'm going to show you really, really quick, 4.1 probability. That thing right there, I'm going to show you how to actually calculate this stuff, but not by hand. Okay, not by hand, but actually using the calculator. Before we get there, let's go to standard deviation. The standard deviation is very similar to the variance. Okay, it's actually just going to be regular sigma, and so really it's just the square root of sigma squared of my variance. So they're kind of related. So that means it's just the square root of everything you see here. Okay, of everything you see that I just wrote down. So x minus mu and then squared times my probability. Okay, so that is what we call my standard deviation. Now again, thank your lucky stars you have a teacher like me who's not requiring you to actually do this by hand. Okay, that's nonsense. Mathematicians really don't do it by hand. They plug it into the calculator. the calculator do it. So let's go through a couple of examples. Okay, we have 2 more examples left and 1 more topic. Okay, so let's erase this. I just want to show you the formulas here because I think they're useful. And I think you should know them, or at least have them down somewhere, because then when you go to this Desmos program, you're going to see it's a lot of stuff here. Okay, it's a lot of stuff, and you're just going to be okay with seeing it because you're already familiar with it. So what is this saying? The probability distribution for the personality inventory test for example 2 is given. Find the variance in standard deviation of the mean distribution. And then I said, hint, use Desmos. So we're going to try to find the variance, and then we're going to try to find the standard deviation. Okay, how do I use Desmos? This is 4.1, guys, right? This is 4.1. So we're going to be using the 4.1 Desmos link. Okay, so what am I going to do? What you're going to do is going to go to classwork. Okay, on your Google Classroom. This is your Google Classroom, right? Go to classwork, hit that, and then you're going to scroll down. So you should see this. You're going to scroll down, scroll down, scroll down, scroll down, scroll down, scroll down until you get to probability. And you're going to see something that says 4.1 probability distributions Desmos link. 4.1 probability distributions Desmos link. What you're going to do now is you're going to click on this. You need to use this Desmos link to do your homework. I don't know how I can be clearer. You cannot do your homework without this link. You will not pass this homework assignment, and you are going to be extremely frustrated and confused if you do not pass. Okay, but you won't pass if you don't use this link. So you need to use this link so you pass, so you're not confused. All right, so click on this link. What you're going to get is this. Okay, this is what you're going to see. I made this link for you guys. I'm going to explain it to the best of my ability. Okay, I'm going to explain it to the best of my ability. Ready? Now, first off, get used to using these links. This whole week, and even in statistics, okay, our next unit, you're going to be using these Desmos links a lot. Like, I mean, you will not be able to pass this class without using these links. Do you understand? I'm not trying to scare you. I'm putting it in reality. I'm just saying you need to make sure you have what we call a Desmos account. So make sure you sign in using your school email. That's your account. It's completely for free. If you have yet to do that, I would do that right now. Sign in, and then when you click, on this link, okay, you will be signed in, and then you can actually hit up here. It will say save, and then you will save this link that you will click to your Desmos account, so that when you do homework, when you do tests, when you do quiz, whatever, you can go back to this Desmos link and pull it up. That's what you need to do. Again, guys, you will not pass this homework quiz even tomorrow without using this link. I mean, literally, that's just a fact. You need to pay attention, okay? Because a lot of you are struggling, which is really unfortunate because of how easy this class truly is. But when I say easy, I mean it is easy because really, for the rest of the class, we're really just plugging things into Desmos over and over and over and over and over and over and over again. Literally, it's just using calculators. Okay? Now that you pass probability, everything's now going to basically be using calculators. You need to know how to use a calculator in order to pass this class. So this is the first calculator I'm going to give you. It's specifically only for 4.1. Hence its title. Okay? What does all this mean? I'm going to show you what it means. Okay, I'm going to show you what it means. First of all, we're going to read. Probability distribution. This is a probability distribution where x sub 1 is the data. x1 is the data. This right here is x1. Okay, I'm highlighting it. That's x1. That's your data. Now notice, y1 equals p of x. P of x is your probability. So this is y1 probability. Now watch. Okay, our actual data set from here, I'll kind of pull this up. This right here, this probability, this thing right here that I'm kind of circling with my mouse, 0.16, 0.22, 0.28, 0.16, 0.22, 0.28, right here, 0.16, 0.22, 0.28. I already have it programmed in there for you. Okay, so what does that mean for us? That means we're going to be using that exact same probability distribution that we made, the one I just showed you on the slides, and we're going to input that here in x, because that's my data, 1, 2, 3, 4, 5. That's my random variable, my discrete random variable. And this is y sub 1. So this is, 0.16, 0.22, 0.28, and so forth. We already have that. Now, what is all this other chunk, you may be asking, right? So what is this? All this other junk? Well, notice here on this slide right here. You see this? This? You can't edit this, but notice while I'm clicking, this slide right here, y1 times y sub 1. Well, what's y1? Or x1 times x sub 1. What's x1? Well, that's my data, x. What's y sub 1? Well, y sub 1 is my probability. X times probability. What was your mean again? Your mean was x times probability. Okay, so when I take x times y, I'm taking this times this gives me that. 2 times that. And we already did this, right? And just a couple slides ago, right? We would go back and we would see that we already did it in your notes. Okay, so we know that column's there, but that column automatically updates. This column automatically updates. That column automatically updates. This column automatically updates. What does this mean? This means, guys, you are only updating these columns, only and always. You are only updating those columns. The rest of this does not matter for you. Do you understand? Okay? It does not matter. That's just there so Desmos can calculate it and so you don't have to. Right? You're welcome, okay? So Desmos calculates this, and so you don't have to calculate it. That's why it's there. The only thing you will change is this, okay? So let's continue on. What is this? What is this? So U is the mean. So down here, you'll see the mean. And you can open these folders in a little bit, and I'm going to show you what that is in just a little bit. V is your variance. Hey, we need to find variance. Yeah, we need to find variance. Okay, we will in a little bit. Standard deviation is S. Awesome. We need to find S too. We need to find that. That's what we're being asked, right? This is what we're being asked? Yes. Okay, awesome. So we're going to be using this. We're going to go to town. Just give me a second. And then F is what we call fair price. I'm going to show you what that means in the next example. And then C is also what we call cost of play. Now, I'm going to also show you that in the next example. The only other thing I need to tell you is that this expected value, it's the same thing as the mean. I'm going to show you that in the next example. So let's get started. What is going on if I know I'm only going to be using these two? And this was my example 2. This was example 2.1, the exact probability distribution that we utilized, right? What happens if I just click on this, the verifying probability distribution? If I click on this, what's going to happen is you're going to see this. So what this does is it really just totals it for you. So what happens if you want to just learn how to do, like when we were verifying the probability distributions just a little while ago, we needed to add everything up, seeing if it was 1. This is a perfect way to do that. If you are saying, if MathXL says, hey, find whether or not this distribution is in the exact probability distribution, what you could do is you could just plug this in, like plug those probabilities in here, okay? And then if it equals 1, if this folder right here that I'm toggling on and off, if this folder equals 1, then boom, it's a probability distribution. So I put that in there just kind of for your convenience. You don't really need to use that at all. Okay, what's the mean? We already found the mean. We found the mean to be 2.94, right? And this is awesome because it calculates it for you, right? So that's what it is. And what it did was it totaled the sum. What it did was it actually totaled all of this together. Okay? It totaled all of that together. And that's what I wanted to do, right? So that's what it is. It totaled it all together. So 0.16, boom, boom, boom. It added all that together, the total. And then I get exactly the same number I got just a couple slides ago, right? Awesome. I'm going to show you what this means, what I need to do here, how I need to adjust that. I'm going to show you what that means in a little bit. Now that we kind of got there, what's my variance? All I have to do, click, there it is. That's it. That's it. That's it. That is all. All you have to do is just make sure you plug these numbers in. Okay? Plug those numbers in. Just right here. Boom, 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 boom. All those, plug them in. Scroll down, and then boom, that's my answer. Now, the one thing that I will tell you that you will forget probably is this. Now watch what I do here when I move this. What happens to my numbers? What happens to my V? What happens to my V, guys? My V kind of is changing, right? Why? And so my table is also changing because this V, this U right here, this U needs to match this. So if that's my mean, that means I need to scroll up to match that. So I need to go back to 2.94. And you can just click on that if you want to, and then you can just change it however you want. But I need to make sure I actually change that value. Okay? That is very important. Do not forget that. I need to make sure that this equals this. Okay? So after I plug my values in, like I did, right? And I get this, I need to make sure that this is the same thing as what I have here. Now that it is the same thing, all I have to do is just click on my variance, and then I scroll down, and that's what it is. So I have 1.6164. I'm going to go over here. I'm going to type that in. What's my variance? My variance is the same thing as sigma squared. On Desmos, though, we had V equals, which is 1.6164. And we use Desmos to do that. Holla. Okay? What's my standard deviation? My standard deviation is the same thing as S on Desmos. So all we have to do is just scroll down. And then I can untoggle that because I don't need it anymore. And then I can just hit standard deviation. And then boom, right there. That's all it is. I'm going to round this to probably 4 decimal places. So 1.2714. So I'm going to go back here and I'm going to type that in. 1.2714. That is how I find my standard deviation and variance. Okay? I hope that makes sense. I really do. I hope it does make sense. Now, let's go on to what we call the expected value. The expected value is this. Of a discrete random variable, the expected value is discrete random equal to the mean of the random variable. So what does that mean? That means I will label it as expected value, E of x. This equals the same thing as my mean, which we said was mu, this weird looking U or M. And then this is my formula. X times the probability of x when I add it all together. Okay, so really, the expected value, it's just the same thing as the mean. Okay, and that's what I have here. So if I go back to my formula, okay, if I go back, right here, I said U equals the mean, but also the expected value. So your mean right here, my expected value, is technically 2.94. Okay, that's for this particular problem. Okay, and so when it asks you for your expected value, you're going to do everything the same, just kind of plug in the numbers, and then once the expected value, you just click on this because it means the exact same thing. Okay, awesome. So expected value and mean the exact same thing. Now let's go through our last example, and this one's a little bit interesting. So think with me. At a raffle, 1,500 tickets are sold at $2 each for 4 prizes of $500, $250, $150, and $75. You buy one ticket And then what is the expected value of your gain? Now, what does that mean? That means if you buy one ticket, okay, and tickets are sold at $2, I lost $2, but I could gain a prize, one of these four prizes, right? I could gain one of those. Just think about it. I'm going to want to find what we call the expected value. I also want to find what we call the fair price. What should these tickets be sold at? If not $2, what should the fair price be? This is my formula for fair price. I'm going to show you that on the 4.1 Desmos, okay, in a little bit. And we also want to interpret it. What does it mean to interpret? So I'm going to spend the majority of my time at Desmos. I'm going to scroll back. So if you haven't had the time to write this down yet, make sure you write it down. Make sure you're following along with the notes because the notes have already written it down for you. And then let's go here. Now, here is what I'm going to be writing. So think about this, okay? I have four prizes. I have 500, 250, 150, and then 75. And then I want to know what is my gain. So my gain is going to be my X's. My gain is going to be my X values. So let's just say I pay $2, okay? I pay $2, and then I actually win the prize of 500, the 500 that we have here, the $500. How much do I make back? Well, technically, think about it. Since I gave $2, but I get $500, do I get 502? Do I get $500? No. What I get is $598. Why? Because I gave $2, but then when I get the $500 back, that those $2 are technically erased. Okay? It's basically filling in the hole that I just gave out, right? So, yeah, it's $598 because I don't have the $2 on me, so I didn't just win like a free $502. I gave the $2 away, so I'm in the negative $200. I'm in negative $2, but then when I get $500, if I do win that raffle ticket, I get $500, but negative 2 plus 500 is $498. So now let's do that with the other ones. I have a prize of 250, 150, and 75. What if I win all of those? Well, my gain right here is not 250, but 248. So now it's 248. My next one right here is going to be 150. It's not 150. It's 148. Okay, because again, I paid dollars. My next one is then 75. So it's not 75, it's 73. Now, these are the four prizes. Now watch. What if I pay $2, but I don't win anything? What if I pay $2 and I don't win anything? How much money do I lose? $2. Okay? I lose $2. Right? Now this is still discrete. Okay? This is still a countable set of data. It's still a whole number. Okay? It's just an integer. So I can still do that. I lose $2. All right? Now, let's go through our probability. Let's adjust these. Remember, I can't adjust these, but I can adjust my probabilities here. Now, my probabilities are going to be a little bit different because we're going to have fractions here. So we have a total of 1,500 tickets of four prizes. You buy one ticket, okay? 1,500 tickets of four prizes. I buy one ticket. So that means there's one ticket that gives me this amount of money, one ticket that gives me the second prize, one ticket that gives me the third prize, one ticket that gives me the fourth prize, right? So that means how many winning tickets are there? There's one winning ticket out of how many total divided by 1,500. Notice how everything else is changing? How many winning tickets are there for the second prize? One winning ticket out of what's the total? 1,500. Okay, same thing here. How many winning tickets for the third prize? One out of what's the total? 1,500. And then for the fourth prize, you guessed it, it's going to be the exact same thing. Okay? Exact same thing. Now, what is the probability here? How many not winning tickets, how many losing tickets are there total? If there's four, 1, 2, 3, 4, If there's 4 winning tickets out of 1,500, what is the total amount of losing tickets? It's a complement. If there's 4 out of 1,500 tickets, that means there is 1,496 total losing tickets out of 1,500. Okay? So 1,496 tickets that are losing tickets. Notice how I stop at 96 because I need to subtract 4 from 1,500. Okay, so 1, 2, 3, 4. There's 4 winning tickets. If I lose everything though, okay, how many losing tickets do I have? So I take those 4 winning tickets out. I'm left with just 1,496 losing tickets out of 1,500. That's my probability. Now notice that it's not a decimal, it's a fraction, but that's okay. Still probability. Now, is this a probability distribution? I can click on this and it says yes, it is, because what it does is it adds all of it together. And then since it is 1, that means we did it correctly, we constructed it correctly. Okay, now it does not ask us, or it does ask us for our mean. It does ask us for our expected value. So awesome. Now what I do is click on this and then boom, this is my total, negative 1.35. So I'm going to go over here, and that's my mean. So my mean, my expected value equals my mean, which equals negative $1.35. What does this mean? This means we're expected to lose on this game $1.35 every single time I pay. That sucks. Okay. Is it even worth it? I don't think so. Okay. And because it's not worth it, let's find the fair price. Okay. So how do I make it more worth it? That means I'm expected to lose every single time I pay a raffle ticket. I'm expected to lose $1.35. I don't want to do that. So how do I make it more fair? Well, first of all, notice this. This we need to change. Notice how this is negative 1.35 and this is still our previous example. So we need to change this to match. So negative 1.35. Now that we change this to match, I can exit out of there. If I wanted to know my variance, I could, but I don't really care to know what my standard deviation, my variance is. I want to scroll down here to what we call the fair price. So go ahead and click on that. Okay. Our cost, C, if we go back up, C is cost to play, right? What was our cost to play? Our cost to play was $2. Whatever the cost to play is, when you get a different example, you'll just change that value. It's $2. And now this formula actually calculates it accordingly. So what should this raffle ticket be to make sure it's fair, it's even? That means I have a good chance of winning or losing. It needs to cost 65 cents. So I'd go over here and I would just say it needs to be 0.65 cents. 65 cents or 65 $0.65. Okay? All right? Actually, this is not correct. It should be this. It's still 65, but so it should be $0.65 or 65 cents. Okay? 65 cents instead of $2. Now, what's the interpretation? So basically, I'm just going to say it. You are expected to lose. So you are expected to lose $1.35 on average. Okay, that's what it means. You're expected to lose, for each ticket you buy, you're expected to lose $1.35 on average. That blows. Okay, so that is the whole lesson. That's the whole lesson. I hope you understood the Desmos here. We're going to be using this a lot. Okay, this is just for 4.1. Make sure you have this pulled up for your homework quiz. We're going to be going through some homework quiz questions on the next lesson. But the next lesson is going to get a little bit more difficult just because it's going to be a little bit more analytical. Okay, so make sure you are doing the homework. Make sure you are paying attention. If you have any questions, let me know. What did we learn? We learned how to distinguish between discrete random variables and continuous. This whole week is just going to be continuous random variables. Next unit, we're going to be doing continuous random variables, but this unit, we're just going to be doing discrete. We also constructed discrete probability distributions. We looked at its graph and determined whether or not it is a probability distribution, so we verified it. And then we found the mean, variance, and standard deviation, as well as the expected value of a discrete probability distribution. We did all of that. Wow. So make sure you do your homework. Okay, make sure you do your homework. All right. The homework quiz is going to be tomorrow, and if you do that at 100%, you will get 2 extra credit points on the homework quiz. Guys, it's been a blast. This is C Squared Mathematics. I'm Mr. Carlson. See you guys later.